I'm just going to pop up quickly. This is what we started with. We spoke about the variance and we spoke about standard deviation. And I'm deeply apologetic that I forgot to push record, even though I was reminded by my class. Now it is recorded and there is proof that you reminded me and I was wrong. So when we do this on our calculator, what we should find is that our mean for group A is 184, and our mean for group B is 184. So what does that tell me? What can I do with that information? It's suspicious. I want to now figure out, okay, well, the mean is 184. What is the spread of our data like? So let's try and figure out what our standard deviation and our variation is. So what we're going to do is we are going to plot all of these points in here. So we know that the mean that we're dealing with is 184 for both of them. Okay. So if I'm looking at the distance from the point, so these values are my x values, and then I'm minusing my mean value. So 182 minus 184 would give me -2. Do you feel comfortable to fill in these tables quick? Cool. Keep them going. Then do the deviation of the mean for group B. Yeah, exactly. Good. That's exactly what I wanted you to find. So what we land up finding is if we add all of these together, our sum lands up being 0. And then if we do the same for group B, we have quite different numbers in group B because we've got this like very small number over here. But what we find is that my sum is also 0. So far what we've tried to do is we've tried to distinguish what's going on in these two data sets. The mean is the same for both of them, so that didn't help us. Then we tried to look at the deviation from the mean, so the distance of all of my different points from the mean. But when I worked out that sum, I get 0 because they cancel each other out. It's the whole situation of giving 4 Rand and taking 4 Rand back. So we've zeroed out, which is a problem. So we still can't get an idea of how spread out our data is. And that's why we land up having to square these numbers so that we actually get a sum. So if I square -2, I'm now going to get a value of 4. So what this column is going to be is that deviation away from the mean squared. And we now know that that is what our variance is called. So pop those values into the table for me, and then we can chat about what those mean and how we get to the next steps. Okay, so we have 4, 4, 4, 0, 1, 0, 1. And if I work out the sum for that, I get a sum of 14. Cool. Now we actually have a number. So this is great. We know our variance is 14. Cool. Let's do group B. Yeah, now we deal with some nice big numbers. And when we work out this one's sum, we get a sum of 2792. Okay, so now we're looking at the variance. Looking at those two variance numbers, what can you tell me about these two different groups? Which one of these groups, group A or group B, is the data more spread out? Yeah, group B, because that number is bigger, right? So because this number over here is bigger, I'm just going to zoom out for a little bit here. Because this number is bigger over here, we know that group B has more spread out data. Yeah, it's nice and easy. It's not so bad. That's all that's telling us. That's literally all it's telling us. Now, the reason we talk about standard deviation from here is because we've got these two values which are really, really big, and they're difficult for us to kind of work with. So that's why we bring in our next step of standard deviation, which is when we now square root them. So we're just going to pop down here quickly. So this is what we were just talking about now. So the average is called the variance. So that's what we were working out. And that is that difference away from the mean, the way that we worked it out over here. So this is that symbol for that. So it's the sum of our values minus the mean all squared. That's what our variance is. I've given you the definition earlier. Who can give me like a nice, very sort of basic way of saying what variance is? Think about what we've just done and put it into your own words. So think about this process and see if you can explain that. Yeah, great. How far each value is from the mean. Cool. But then what do we have to do with that? And then we've got to square it. That's all variance is. Variance is how far each value is away from the mean squared, and then the sum of that. That's it. That's all variance is. So the two values that we've just worked out now for group A and for group B of 14 and 2792, those are our variances for the two different data sets. And we can write it as our little standard deviation sign squared or S squared, or we can write it as this formula over here, which you now know exactly what it is. Yeah, those are our variances of our two data sets. So this is of group A, that's our variance. That's our variance of group B. So the bigger the variance, the more spread out the data would be. But like we just spoke about, those numbers are really big and they can be a little bit confusing. So instead of using those numbers, we think, well, why don't we just square root them? Because now they're these huge numbers. So the standard deviation is the square root of our variance, or it's just our little standard deviation sign, or we just call it S. So now if I wanted the standard deviation of group A, it would be the square root of 14. Pop that into my calculator. And we get 3,74. And the other one is the square root of 2792. Which gives us 52,84. Good. So what do these values mean in context of the question? It means that group A, the values are closer together. So this one over here. And that's all it means. So our values are closer together in group A, or you could say in group B, our values are more spread apart. Okay. So I'm going to give you a question which looks similar to this one, but now I've walked you through this one. So the next one I want you to be able to do by yourselves. And then we'll go through those answers. And then after that, we'll look at how to do this on the calculator so that you will be prepared for whatever they may ask you in any of your exams. But I hope that the concept makes sense and that it seems a lot less scary than it is. Let's put in our other thing here. This could also be written as the square root of the sum. Okay, cool. So Rebecca measures the height of 7 of her friends and 7 of her family members. The data is recorded in the tables below. First mission is to find the mean of each group. Second mission, to complete the tables, and then to work out the variance and the standard deviation for both groups. I will give you 5 human Earth minutes. How are we doing? You've had 3 minutes so far. 2 more. And if you need more than that, just let me know. The silence is worrying me, guys. What is happening on that side? Where are you in the process? Or have you all gone to have a cup of tea? Where are we at? Okay, no, that's fine. If you're trying, I don't want to interrupt you. As long as you're doing work and there's not just like zoning out happening on the other side of the screen. I mean, a cup of tea always sounds lovely in fairness. You can have a cup of tea in half an hour. First mission is to just get the mean of your two groups. And remember, you can do that on your calculator. So you can do that nice and quick. Yep, I got that same mean. So for friends. Yep, Beverly, I agree with you there. Okay, cool. So then we know what our mean is. So then all we need to do is, how about, I'm going to make your life even easier. You can just make it 169 for both of them. You don't have to if you've done it with the decimals, but if you want to make your life easier. So then we'll have like -7, for example. But what happened? Did you leave and then come back? Oh no, you closed Chrome. Gimbly for which one? The first one. Oh yeah. So this absolutely is, it has got a decimal place. So if you're wanting to do it properly, it absolutely would be 169,29, and then all of these will have decimals. But what I was saying is, if that 29 is making your life a mission, I'm fine for you to just round it off to 169 to work these out. But if you kept the decimal place, then that's absolutely fine. I mean, that's more accurate, so it's more than fine. Uyanda coming in with the facts. Look, it's unlikely that they'll give you one with a decimal. But no, if it was given to you in a test or an exam, please absolutely keep the decimal places. We're just being sneaky here. Sometimes a little sneak has to be allowed, but not in tests. No sneak in tests. But and it's because you did it the proper way. You did it with the decimals. That's the only reason the numbers are a little bit different. So what we see, oh, I've got one more thing I've got to fill in, sorry. I know this is a schlep. For the most part, we can get away with doing it on our calculator, but just wanted to make sure that you knew how to do this. I know it is draining. It's a lot. Oh, my cat just jumped up. So what we land up with is this over here is our variance of our friends, and that is our variance of our family. So we now know what our variance is. So we can write that over here. So let's do this friends and family. So our variance, which is our funny symbol squared for friends, is 420, which means our standard deviation is the square root of 420, which gives us 20,49. And our family, our variance is 5432. Well, that's quite a cool number. And our standard deviation is 73,70. So Uyanda, you might, because you've got your decimal places, it's very possible that it would be 0.48 and not 0.49. So now if we had to have a look at this, so we've got our friends and our family, what can you tell me about the standard deviation or the spread of the data? What can you tell me about it? All of that work for this one last question. What do they tell you about the spread of the data? Look at your two different values. So you've got your 20 something and then you've got your 73 something. What do those two values? The friend's height. So Uyanda, this is still quite a big number. So for standard deviation, it's still quite a high number. So it means that our values are still spread apart, but it is definitely lower than this value. So we would say that the spread of the data for the friends is less spread out than the data for the family. Or you could say the heights. So if that number was really, really, really low, we could have said that. Yeah, you can just compare. And then you get your marks. So I'm saying standard deviation is made to seem as if it's this whole big deal, and it's really not. It's just made there to confuse you. And we're not going to get confused by it. Okay, now that was painful, but it's the last time I'll ever make you do that manually, I promise. From now on, we're going to use our calculator because I feel like you know how to do this manually if you have to. So I'm just going to zoom out a little bit so you can take a screenshot if you would like one, and then we're going to quickly do this on the calculator. You'll support that or not after the 19th? What will you support or not? Okay. Okay. We've actually already written this up earlier, and we've written, but what we'll do is we'll quickly do it now for our standard deviation. So we have a frequency table happening over here. What we've got is we are trying to find our different values. So we have a set of 100 grade 11 learners. They had an exam question which was marked out of 6 marks. So this is telling us how many people got what marks for the 6-mark question. So we have 4 people who got 1 mark out of 6, 10 people who got 2 marks out of 6, 27 people who got 3 marks out of 6, as you can see. So what we've got is we have a frequency table. Now we've already put our calculator into stats mode, into frequency mode. If you hadn't done that already, then all you need to do is on your calculator, you're going to go shift mode. You go to stat. So whichever one your number is, my number is number 4, but make sure you find where your stat is. And then it's going to say frequency with a question mark, and you are going to say 1 on. Now our frequency is on, and you can just push AC. Now we're going to do what we need to do for our standard deviation and all those good things. So now you can just go mode, and then click on stat. So for me, it's number 3, but it must be whatever yours is. And then you're going to click on number 1. And you're going to put in all of your X values, and you're going to put in your frequency. Okay, so you do that so long. And once you've put it in, all you need to do is push AC, and then let me know, and then I can help from there. And then when we're ready for what we're needing, we're going to say shift, and then number 1. And then we're going to go to number 4, which says var. And then we've got a whole lot of options. So we have an option for number 1, which is N, option 2, which is our mean, option 3, which looks like this, and then option 4, which looks like this. Yes, AC. We only care about 1, 2, and 3 for now. So you can find my N, which is my sample size, my mean, my standard deviation, and then you're going to tell me what my variance is. And to find variance, all we have to do is we take our standard deviation and we square it. And then you can give me those values. No problem. I'm happy to. From where? Are you fine with the calculator instructions? Okay. So if we've done this to our calculator, these are our options. So 1 gives us our sample size. 2 is going to give us our mean. 3 is going to give us our standard deviation. So we're going to get those numbers. And then for the last part, all we're going to do is we're going to take our standard deviation and we're going to square it. And that's going to give us our variance. Beverly, where is that number coming from? For which one of your answers did you get the 12,29? Yes, 1,37. Yay! 1,37 is our variance, and our standard deviation will be the 1,17. Beverly, did you get the same values for me for N and for your mean? Because maybe one of the numbers got put in incorrectly. Yay! Progress. Okay. Can we admit that standard deviation and variance is not as scary as it seems? It's a bit of a pain, but it's not scary. Okay. So for our last little bit of the lesson, we're going to do hopefully 2, but if not, we can get through one more past paper question. And you have got your quiz tonight, and then we get to start the fun joys of probability next week, Tuesday, which is very exciting. Oh, why is this not loading? Oh, no, I didn't save anything that we did. That's frustrating. Okay. That's okay. We will figure out what we need to do from here. Okay, so let's start with this one. Yes, the joys. I love probability. Probability is one of my favorite sections. So I'm looking forward to teaching it, and I am hopefully going to make you enjoy probability too. That's the hope. Okay, so this is from a past paper. The table below shows the recorded monthly rainfall in millimeters measured in Silver Lakes in Pretoria for the months of December. The recordings were made for the period 2004 to 2015. So we've got all of those values. Which year's rainfall will decrease the mean December rainfall the most? So which one of these will decrease our mean the most? What is this essentially asking? It's asking us something. Yeah, good. We wonder why. Good, because it's an outlier. And outliers affect your mean. Good, okay. Calculate the standard deviation for the rainfall in December. You can use your calculator. You do not need to put in all of the years. You can just put in the values, and that's absolutely fine. Nice, Kimberly, I agree. Now we're trying to find what our standard deviation is going to be. Got a slightly different number, Kimberly. I'll check mine. So if you don't want your frequency on, all you have to do is push mode and then push number 1. So when you want to turn frequency off, you just push mode and then push the number 1. Kimberly, I think put your numbers in again. I think you've put in one of your numbers slightly wrong. I did just double check mine. Oh yeah, so if you have 2 columns, you don't need to worry. You can just put it in the X value. It will automatically know that that's what it's working out. If you don't have X and frequency, it knows that you're just working out X. So you can keep the 2 columns and you just only fill in X. Because remember, your calculator is smart. Beverly, that is the same answer as me. Now, the next question, it seems like it's a scary question, but it's actually not. It says determine the percentage of the data points for the rainfall in December which lie within 1 standard deviation of the mean. So all we have to do now is we have to figure out what our mean is. We need to plus and minus our standard deviation, and then we need to see which values in here fall into that range that we figured out. So the first goal is to find your mean, which you can do now easily on your calculator because you've inputted your values already. So we want to take our mean and we want to minus our standard deviation, and that's going to be the lower limit. And then we're going to take our mean and we're going to add our standard deviation, and that's going to be our upper limit. Yeah, good. Okay, so your mean is 164. Absolutely. So now we just need to plus and minus our standard deviation. So we should land up with 98,82 and 229,18. So that means that's within 1 standard deviation of our mean. Now what you need to do is you need to find how many data points fit into that range. Yeah, good. There are 8 of them. So this one doesn't fit into the range. This one doesn't fit in, but this one does. This one does. This one does. This one does. This one doesn't. This one does. This one does. This one does. This one does. This one doesn't. So we have 8 that fall into the range, but they've asked for the percentage of the data points. So how many data points are there in total? 12. So all we have to do is we say 8 over 12, and we get that as a percentage, which is about 66.67%. Yeah. Well, no, that's as a decimal, Abu. Now you've got to times by 100 to get percentage. Yeah. So that's saying that like about 67% of our data fits within 1 standard deviation of the mean. The weird fraction thing is because you have frequency mode on. So if you click mode 1, then that fraction thing will go away. Yeah,